Structural health monitoring, SHM, is a field of engineering that deals with diagnosis and monitoring of structures during their operation. The primary goal of SHM is detection, identification, assessment, and monitoring of flaws or fault conditions that affect or may affect the future safety or performance of structures. The process of structural health monitoring by the acoustic emission method. The process of AE structural health monitoring can be divided into the following typical stages. 1. AE SHM procedure development. 2. Sensing. 3. Diagnosis. 4. Monitoring. And 5th, prediction. AE SHM procedure development. The first stage of procedure development starts with the collection of all necessary information regarding the structure, its design and materials, operational conditions, statistics of failures, etc. In addition, laboratory or full-scale tests or both are conducted on structures with known flaws or faults at a known stage of development in order to develop the ability to detect, identify, and assess specific flaws or faults. Based on the collected information, the optimal instrumentation, methods of data acquisition, and data analysis and loading procedures are established. Sensing. Sensing is a process of data capture and measurement. It involves measurement of AE as well as parametric data such as pressure, temperature, strain, and other information according to the developed structural health monitoring procedure. There are several important aspects to address during the sensing stage. It is important to check that data collected during the data acquisition process is valid and can be satisfactorily used for the purposes defined in the developed SHM procedure. If this is not the case, additional measurements with a different setup or loading, operational or environmental conditions, or both may be required. Also, during the sensing process, a short evaluation of the structure should be performed to identify or rule out possible conditions that may threaten the structure immediately or in the short term. Diagnosis. Diagnosis is one of the primary tasks of the SHM process. It effectively distinguishes typical noise-related AE from SHM-related AE. The objectives of the diagnosis process are not only to detect and locate flaws or faults, as in typical NDE, but also to identify and assess them. Diagnosis is performed based on collected data, numerical modeling including finite element analysis, history of the inspected structure, local application of different NDE methods, material and other relevant investigations. Monitoring. Monitoring is performed to assess the condition of a structure over time. It is performed periodically or continuously, depending on the particular application. For best results, it is recommended to identify quantitative or qualitative AE characteristics, or both, that are changing with the flaw or fault development. It is important to perform monitoring under normal operational and environmental conditions of a structure. If a change in stress or operational or environmental conditions occurs for any reason, or a structure has been subjected to extreme conditions and trauma, it may require a change in the monitoring policy. Another important goal of monitoring is to identify conditions causing flaw or fault origination and development in the inspected structure. Examples of such conditions are fatigue, mechanical and thermal overstresses, etc. Prediction. The goals of prediction can include assessment of suitability for continued service of structures when a proven and statistically valid experience or database is gathered. Defining an appropriate re-inspection or monitoring policy based on diagnostic and monitoring results. Providing information necessary for condition-based maintenance decisions. Prediction, which is normally carried out based on diagnostic results, several monitoring cycles, and in conjunction with information about the structure, its history, and all known measurable or non-measurable risk factors.